हो गया.
Respected Chairman Sir, Dr. Abhinav Sahaji, my fellow colleagues and participants who have joined us online. It is a great pleasure for me to welcome you all to this session of our monthly lecture series. Today is the 21st lecture. So for last 20 months, 21 months, we have started these series. Yes, yes. On this scientific interaction, and during this journey, we we have had very nice presentations by eminent scientific personnels, professors, and uh, scientists who have actually worked with different organizations at different levels on different subjects of environment. The idea of this very uh, series is just to have a continuing education program for not only for our officials, but the students, the researchers, and other professionals who are working in the field. And I'm very pleased to share with you that it has been appreciated widely. Uh, I don't know how many people have joined us today, but in most of the programs, we have very good attendance. We expect some more people to join us. Today's lecture is on reviving springs in Tehri, Garhwal in the Himalayas through integrated spring shed water management. The topic is looks very interesting, and because water pollution and the quality of water, we were yesterday also we were discussing with our young colleagues also about the importance of water and its quality. So in that context also, I feel that today's topic is going to be a very interesting and a good learning for all of us, right?
Yes.
So on behalf of this board, our chairman sir, and my own personal behalf, I welcome Dr. Abhinav Sahaji, who is assistant professor with MIT University at Patna. Uh, Welcome you, sir, and request all of you to have give a big hand to Dr. Sahaj. We are very pleased to welcome our chairman, sir, who has been the inspiration and a source of motivation for all of us. He has very clear ideas uh, about how to go in the field of and of our work, not only our regulatory work, but he is always keen that how we can outreach and make our presence in the scientific world also. Not only our regulatory uh, functions, but whatever the information we have, whatever work we do in the field of science, it is to be focused for the betterment of common man and how best we can reach for the conservation of environment and with our goal of pollution control. And I'm very pleased to see that our young colleagues are here. So it is a opportunity for you people also. And as I have discussed, and we were discussing rather in the presence of chairman sir. So it is a very good opportunity, and you can just think that it is in that series also that we are organizing this type of lectures. It will be of some help and it will give you some ideas what Chairman Sir was telling you yesterday. So you can pick up some ideas for further advanced research in the field. So I welcome you, sir, uh, to this and hope that you will be guiding us and our young colleagues also. So, and I also welcome all the participants who have joined us offline as well as online, and hope that this session will be beneficial for all of us. So, thank you, and I would like to request Chairman Sir for his opening remarks. Good afternoon, everybody.
Good afternoon, sir.
Respected Dr. Abhinav Sahai, Assistant Professor, Department of Environment Science, MIT University, colleagues, and our new joining GRFs. In this lecture series, this is the 21st lecture, and we have started some 2 years back. That the lecture series is mainly focused on diverse aspects of environment and pollution. In fact, it is better to know the different aspects of the environment and pollutions, because then you can find out your ways how to proceed further for your research. In fact, throughout this series, so we are mainly focusing on air pollution. Thanks to Dr. Saha, he is an air pollution expert. So we are talking about the emissions, but now we are changing the track, and in this lecture we are focusing on the sequestration aspect also. Through, in fact, it is not a sequestration, but it is a total ecosystems of this region. I was lucky enough that because I have seen this Tehri Garhwal. Many of you might have not seen, and you will not able to see also, because the Tehri Garhwal, most of the area, the Tehri Garhwal city is submerged now, so you cannot go there. The nearest there is a new Tehri was also established, and I have seen the very beautiful place, that Sangam of Bilangana and Bhagirathi. It is one of the best place, but now you won't be able to see it. There is a big dam, Tehri Dam, you might have heard it. So there is a lot of challenges regarding the watershed development, and specifically the spring shed. I think it is an offshoot of the watershed development. So these challenges, because the ecology of the whole region is disturbed because of this big water body, it's in the center of this. So the ecological restoration of this area is very essential, and I hope that Dr. Abhinav Sahai will able to deal with this, how to tackle this spring shed development and the whole ecology of this region. Thank you very much. Thank you, sir. और मैं अब अनुरोध करना चाहूंगा हमारे कलीग श्री अरुण जी से कि वो डॉक्टर सहाय का इंट्रोडक्शन, फॉर्मल इंट्रोडक्शन हमारे पार्टिसिपेंट से। अरुण जी, प्लीज।
Thank you, Govinji. Respected Chairman Sir, Dr. Abhinav ji, Dr. Sahai, Dr. Govinji, and our colleague newcomers. We are thankful to Dr. Abhinav Sahai ji that he has given some time for you, for us also. He is an assistant professor in the Department of Environmental Science, currently pursuing his PhD in Environmental Science from Uttarakhand Technical University. He holds a master degree in the Environmental Management from Forest Research University, Dehradun, and earned a bachelor degree honors in Environmental Science, where he received recognition as a gold medalist from the Patna University. With an extensive teaching tenure Spanning 9 years, Dr. Abhinav has made substantial contribution to academia. His research interests primarily focus on pivotal research areas such as Himalayan spring regeneration, natural resource conservation and management, and environmental pollution monitoring and abatement. Dr. Abhinav has authored 12 research papers, including a notebook within his field. Thank you, sir.
Thank you, Arunji. So we are privileged to have with us an eminent scientist and distinguished faculty of MIT University, Patna. And I am really very pleased to note that you are from Patna University and a gold medalist. By the way, environmental sciences, which department?
Sir, Science College. In Science College, there is a voluntary course run by botany.
Botany also, yes.
Botany.
Yeah, I was just finding out that it was from Department of Botany also, because I am also a product of that very university, and so it is really a very nice to note. So very humbly, I request you to present your talk on the subject. Dr. Sai, please.
Thank you, sir. First of all, I would like to extend my regards to Chairman, sir, Bihar State Pollution Control Board, dear colleagues, researchers, and all the participants that are present in this today's lecture. Today, I'm going to share my research on the topic reviving Himalayan springs in Tehri Garhwal region through integrated spring shade management approach. This is my PhD research topic. After doing my master's from Forest Research Institute, I was teaching in a college affiliated to HNB Garhwal University. There I met my colleague and HOD, Dr. RBP Singh. RBP Singh is an advisor in an NGO called HimCon, which works at grassroots level to provide livelihood and to protect the environment of Himalayan region, particularly in Tehri Garhwal region. Through him, I visited this village, Sabli village in Tehri Garhwal region, and there I understood the importance of the springs. Sabli is a far-flung village, and access to water is limited. Access to municipal water supply is limited for few hours. Most of the villagers are dependent on spring water. Most of the villagers are dependent on spring water for irrigation purposes, for feeding their animals, or they consider water. They consider that this water has some nutritious value. So I'm going to discuss this topic. So let's start with the first slide. Next slide. Introduction to the springs. Springs are natural water sources that emerge from the ground, typically where the water table intersects the land surface. Springs are actually the water that seeps out of the earth's surface where aquifers are exposed. What are aquifers? You all know that aquifers are specialized rock formations that are made up of limestone or sandstone that stores water that penetrates rainwater that penetrates deep into the soil, and then aquifers releases water. In plain region, we extract aquifer water through hand pumps, through bore wells, through artesian wells. But in hilly regions, these groundwater is available through special orifices that are present along the hillsides, and they are termed as springs. Springs range in size from intermittent seeps, which flow only after much rain, to huge pools flowing hundreds of liters daily. So there are different types of springs. Some springs release water in very small quantities. Full day per liter water that they discharge would be around 4 to 5 liters. And then there are some springs that can release around 1,000, 2,000 liters of water per day. The springs are common in Himalayan region due to the steep terrain. Springs can be seasonal or perennial. Next, we are going to understand the various types of springs. Springs are classified into different types, like depression springs, contact springs, fault springs, fracture springs, and cast springs. So, depression springs are the springs that occur when there is a dip in the topography and topography of the mountain, and it allows the groundwater to come into contact with the surface. Then this water seeps out as a spring. The next is contact spring. Contact springs occur in between rocks of high permeability, which are in contact with rocks of low permeability. This type of springs generally occur in one line across the hillside. If you visit some hill station, you must have seen that there is some tap that is running continuously. We people from plain consider it as the people are wasting water. We think that this water is coming from some municipal supply, but actually this is spring water. They have created a spring box, and then this water is releasing from these points. Next type of spring is fault springs. It occurs at fault, which can put impermeable rock in contact with the underground aquifer. Then the water that is present in that underground aquifer is released through some orifice. Next is fracture spring. It occurs when fracture or joints in the rock meet the shallow or deep aquifers. And the last is the cast springs. Cast springs form through the dissolution of the soluble rock like limestone and dolomite by slightly acidic groundwater. Actually, what happens when rainwater percolates into the soil, it dissolves some organic matter and it is slightly acidic. This slightly acidic nature of water actually dissolves the calcium carbonate that is present in limestone, and special types of conduits and fractures and caves are developed, which stores infiltrated water, and then this water emerges at the surface as a spring. Now, what is the importance? Next slide. What is the importance of spring? Springs play a crucial role in providing fresh water for various purposes, including drinking, irrigation, and sustaining ecosystems. Though all the villages now have adequate water supply through municipal water, but villagers try to consume spring water because they consider that it has some medicinal properties. You must have heard about different spring water brands, like Evian is a brand that sells black water, or that sells slightly alkaline water. It is considered that if we drink alkaline water, it will balance the pH of our blood, and then we will be more fit, and less diseases will occur in our body. So there is a practice in the hills that generally women in these villages, they visit this spring, and per day they generally go for 2 to 3 visits, and they collect water in special containers of around 15-liter capacity. They consider that by drinking this water, the problems related to renal calculi can be solved. Problems related to indigestion can be easily solved. Additionally, springs often hold cultural and spiritual significance in many societies, particularly in mountainous regions like Himalayas. They are revered as sources of purity and life, and are often associated with rituals and traditions. There is a belief in hilly region that the springs are abode of Lord Vishnu, and generally near a spring area, a small temple or a religious plant is planted, like people is planted, and open defecation or any type of activity like cutting of fodder or removal of wild plants is not allowed in this region. Now, next slide. Now, I'm going to discuss the threats to the Himalayan springs. The various threats that springs face, particularly in the context of Tehri Garhwal Himalayas, are first, deforestation. We all know that deforestation is removal of trees from a wild area, and for the requirement of fuel wood, for the requirement of fodder, generally villagers, they remove trees, they remove tree seedlings, and due to this, what happens that the hydrological cycle is affected, and due to loss of forest cover, water infiltration is reduced, reducing the recharge capacity, and spring flow, spring discharge is getting affected, and water is available for very few months. During monsoon, most of the in this region, most of the springs are functional just after monsoon, and they become defunct in the month of March, April, in early summer. Next is over extraction of water. In these villages, in villages that are present in that is present in Tehri, Garhwal, the livelihood, the source of livelihood is agriculture, or the source of livelihood is rearing animals, and for all these demands, the spring water is used. The spring water is actually channelized into smaller tanks. Here, water is stored in cement tanks, and then this water is used for daily course. Then increased demand for water, particularly for irrigation, domestic use, and hydropower generation, often leads to over extraction of groundwater resources. This overuse can lower the water table and diminish the spring flow, impacting the reliability and sustainability of the spring as water sources. Next threat is pollution. While carrying out this research, we have when we have analyzed the water samples from different springs, we have found that there are coliform bacteria that is present in the spring water. Generally, we consider that groundwater is purest form of water because it is filtered by different layers of soil and it is not in direct contact with any type of sewage. But due to the construction of houses in higher altitudes near the spring, through the release of the septic tank leakages, the water is getting contaminated. And we have also observed that the spring water has a higher heavy metal content, or spring water has a higher BOD content. Though DO is lesser because it is not in direct contact with the air. So pollution from agricultural runoff, septic tanks, and untreated sewage contaminates groundwater and surface water sources, including springs. Pollutants such as pesticides, fertilizers, heavy metals, and pathogens degrade water quality, posing health risks to humans and ecological communities dependent on the springs. We know that 70% of human diseases is caused by contaminated water. More than 70% diseases is caused by contaminated water. So if the major source, the main source of water is polluted of these villages, what would happen? That the infection rate or the spread of diseases would increase. And in these villages, generally, general villagers are involved in farming of vegetables like tomatoes or other different type of fruits. So they are using huge quantities of pesticides, and this is the reason why groundwater is getting contaminated. The next threat is climate change. Climate change exacerbates existing threats to the spring in the Himalayan region, leading to alteration in precipitation pattern, temperature regimes, and glacial meltwater contribution. These changes can disrupt the hydrological balance, affecting the timing and magnitude of spring flows and exacerbating water stress in the region. What we are observing that due to climate change, the spread of rainfall during the monsoon is not adequate. Actually, rainfall is happening for few weeks, and due to this reason, the percolation of rainwater as groundwater is not happening, and most of the water is getting wasted. So due to this reason, the proper recharge of spring is not happening, and the hydrological balance in this region is getting affected. Next slide. What are the impacts of drying Himalayan springs? The various impacts of drying Himalayan springs are water scarcity, ecological degradation, impact on livelihoods, and social and economic disruption. So let's discuss water scarcity. Drying Himalayan springs lead to reduced water availability impacting communities that depend on them for drinking water, irrigation, and livestock. This scarcity can lead to hardships, increased competition for water resources, and challenges in meeting daily water needs, particularly during dry seasons. And it may also result in migration of people. When enough water is not available, then there would be lesser livelihood opportunities in this region. Then the second impact is ecological degradation. Drying springs disrupt the delicate ecological balance in the Himalayan region. These springs support diverse ecosystems, including unique flora and fauna, adapted to their specific hydrological conditions. Reduced flow or complete drying of springs can result in habitat loss, decline in biodiversity, and disruption of ecosystem services, impacting both terrestrial and aquatic species. Next impact is impact on livelihood. Many communities in the Himalayas rely on springs for agriculture, livestock grazing, and other livelihood activities. The drying of springs can lead to crop failures, reduced agricultural productivity, and loss of income for farmers and pastoralists. This can exacerbate poverty and food insecurity, particularly in remote and marginalized communities dependent on subsistence agriculture. Though we know that most of the rivers in India originate from Himalayas, but there is a popular saying in Himalayan region. In Hindi, there is a phrase that "Pahar ka pani or pahar ki jawani, pahar ke kaam nahi aate." Most of the rivers are originating in Himalayan region, but these rivers move to plains and round the year water availability is not there. So these people are dependent on spring. And so it is important to protect this spring because village economy is dependent directly on these spring water, groundwater sources. Next is social and economic disruption. The drying of Himalayan springs can trigger social and economic disruptions in affected community. Water scarcity may lead to conflicts over water resources, exacerbating tension among different user groups. Additionally, economic activities depend on reliable water resources such as tourism and hydropower generation. It may be negatively impacted, affecting local economies and livelihood opportunities. So the tourism in these Himalayan region is also dependent on the spring. If these springs are affected, if these springs are drying, then it will cause social and economic disruption. Next slide. Now, next subtopic is introduction to spring shed. As we all know that watershed, we know what is watershed. Watershed is a region from where a water body, a pond, a lake or river receives its water. It is known as a watershed of a water body. So spring shed is actually a smaller area. Watershed is a larger area. Spring shed is a smaller part of watershed. It is the area from which a particular spring receives its water, or we can say that spring shed is a recharge area of a particular spring. Generally, it is present in a few kilometer square region. So spring sheds are defined as areas that contribute water to a spring. They are crucial for water resource management. They are particularly important in the Himalayan region where climate change and other anthropogenic factors are causing springs to dry up. In this diagram, we can say that here is a village, and in this village, the spring is present, and on the opposite side of the mountain, the recharge area of village to spring is present. Next slide. So in this figure, this is actually a spring box where spring groundwater is released. So when several institutions in Uttarakhand like PSI, Chirag, Incon, Himalaya Seva Sangh, when they were doing research in this field, then the central government through Niti Aayog had published a report related to spring shed management. Niti Aayog, or the National Institution for Transforming India, is a policy think tank of the Government of India that provides strategic and technical advice on various aspects of governance and policy formulation. The report focuses specifically on spring shed management, which refers to the holistic management of the entire watershed area that contributes to the flow of springs. It emphasizes the interconnectedness of land, water, and ecosystem in sustaining spring flow and water availability. Next slide. So now we are going to discuss what is integrated spring shed management. So integrated spring shed management approach actually revolves around few key components, which includes: first is hydrological studies. Once we and the other stakeholders that are present in a village decide that we are going to protect these springs, we are going to do some interventions to protect this spring, then we have to first carry out a general survey to identify the spring. Then we carry out hydrological studies. What is hydrological study? It is understanding the geological and hydrological characteristics of the spring shed to access groundwater recharge, flow pathways, and vulnerability to pollution. Then second key component is community participation. For protecting a groundwater source, efforts from NGO, efforts from government is not enough. We need involvement of the local communities. So community in participation involves local communities, stakeholders, and indigenous knowledge holders in decision-making process, conservation efforts, and sustainable resource management practices. For example, in Uttarakhand, there are some people that have the basic knowledge how to create a spring box, how to create nalas, that are different type of spring that is present in Kumaon region of Uttarakhand. Conservation, next key component is conservation measures. It includes implementing land and water conservation techniques such as reforestation, soil erosion control, sustainable land use practices, and water harvesting to protect and enhance spring recharge and flow. Next key component is adaptive management. Adopting adaptive management strategies to respond to changing environmental conditions, emerging threats and uncertainties, ensuring resilience and sustainability of a spring shed ecosystem. So next key component is adaptive management. As we know that due to climate change, the frequency of rainfall has been reduced, or water is getting contaminated due to septic tank leakages, then we need to take some adaptive measures. Some of the adaptive measures include creation of recharge pits to increase the groundwater infiltration, increase the rainwater infiltration. Then other practices include creation of Mahila Mandal Dals that will protect the spring areas or their recharge areas. And it also includes creation of nurseries or creation of terraces to reduce the soil erosion, creation of nursery to start seedlings of native plants, seedling of fruit plants, so that it can help in soil erosion control. It can help in providing a source of livelihood to the villagers. So these all strategies are under adaptive management. Next is conservation measures. Conservation measures are essential for protecting and enhancing the health of springs and their surrounding ecosystem, thereby ensuring the sustainability of water resources in the region. Some of the conservation measures are reforestation, sustainable land use practices, water conservation techniques, and soil erosion control. Next slide. Now, other important topic is stakeholder engagement. So stakeholder engagement refers to the involvement of various actors, including government agencies, local communities, NGOs, researchers, and other relevant parties in decision-making and collaborative efforts aimed at spring revival and management. Engaging stakeholders fosters ownership, participation, and shared responsibility, leading to more effective and sustainable outcomes. Collaboration with the government agencies at national, state, and local level is essential for policy support, regulatory frameworks, funding, and coordination of springshed management initiatives. Empowering and involving local communities in springshed management is crucial for promoting social equity, cultural sensitivity, and community resilience. Communities often possess valuable traditional knowledge and practices that can inform decision making and contribute to the success of conservation efforts. Partnerships with NGO and civil society organizations can provide technical expertise, capacity building, and grassroots support for this springshed management projects. Next is collaboration with researchers and academia can facilitate scientific research, data collection, monitoring, and evaluation of springshed management interventions. Their expertise can inform evidence-based decision-making and contribute to innovation and knowledge exchange. Next slide. Now, we are going to see the study area. In this slide, you are visualizing this is Tehri Dam that Sir had discussed. This is Tehri Dam. And Tehri Garhwal is one of the mountainous districts of the Uttarakhand. And this district was included in Uttarakhand after the state was carved out of Uttar Pradesh on 9th November 2000. Reorganization of district took place subsequently when Jhakoli block of the district was included in the neighboring Rudraprayag district. The district is bounded by Uttar Kashi district in the north, Rudraprayag district in the east, Pauri Garhwal district in south, and Dehradun district in the west. The geographical area of the district is around 3,796 kilometers square. So this is the location map of Tehri. My study area is near Chamba, which is Sabli village. Next slide. So now we are going to discuss the case study, which is related to reviving the springs. This case study was carried out with the help of a Himalayan NGO by the name Himpon. It is part of Himalayas Seva Sangh. So we have carried out this research during 2018 to 2020. Several MSc students were involved to carry out this research. This study was carried out during 2018 to 2020. 7 sites in Sabli village where 7 springs were selected. These are the various springs that were identified in the Sabli village, and their latitudinal, longitudinal position and altitude is mentioned. The name of the springs or study sites are Suri Dhara, Pani Ka Khal, Muria Parihar 1, Muria Parihar 2, Osh Ka Pani, Chamari Dhara, and Muriao Dhara. So next, this is the study area. This is your village, Sabli village, and various springs are located in this study area. Next. In this second image, actually, the springs are mapped in the study area, and the boundary of the Sabli village is marked through your Google Earth platform. Next slide. In the next slide, the area that is shaded with blue region is actually the catchment area or recharge area from where the springs receives its water. Now, next slide, that is hydrogeology. The spring water or the quantity or quality of spring water or appearance of the spring solely depends on the hydrogeology of the region. In Tehri Garhwal district, groundwater is found in various forms due to specific geological and hydrological conditions. Groundwater exists in cracks and fractures with rocks like crystalline and metasedimentary rocks. It is also present in well-vegetated plains and valleys, as well as underground caves formed by limestone and dolomite rocks. There are various types of springs that are present in Tehri Garhwal. They include your seepage type of spring. They include your karst springs. Next, groundwater emerges as springs and seepage, and they are locally called srots, dhara, and naulas under favorable physiographic conditions, such as in gently sloping areas, broad valleys of rivers, and along the lithological contacts. Rainfall is the principal source of groundwater replenishment. A part of the precipitation received, either as rainfall or snowfall. You can see in this diagram that Tehri Garhwal receives snowfall during winter. So snow meltwater is also contributing to the groundwater. And some of this water is lost in the atmosphere as evaporation and evapotranspiration from soils and plants. Another considerable part flows as surface runoff due to extremely rugged and undulating topography with steep slope, and the remaining part directly infiltrates through the soil profile to form groundwater storage in joints, fractures, and fissures that ultimately gets released as a spring. In Tehri Garhwal district, groundwater flows out of a spring and seepages where the water table intersects the ground surface. Next slide. Now I am going to introduce the NGO through which I have done this research. I am a member of this NGO. The name of the NGO is HIMCON, Himalaya Consortium for Himalayan Conservation. HIMCON is focused for preserving the Himalayan environment and promoting the welfare of its inhabitants. As a non-profit organization deeply rooted in Himalayan region, we understand the importance of safeguarding its unique ecology and cultural heritage. Founded with a vision to promote the Himalayan ecosystem and upliftment of the communities that call it home, HIMCON stands as a beacon of hope for sustainable development and conservation in the region. There are various types of activities in which HIMCON is involved. First activity is related to spring recharge. Second activity is related to cultivation of medicinal herbs or cultivation of culinary herbs. They are promoting cultivation of herbs like rosemary or oregano. In hill, there is some problem that when farmers plant vegetables in their field, there is problem from the monkeys, there is problem from wild animals like monkeys or wild boars, and they damage the crop. But when these plants are planted like rosemary or any oregano, it is observed that wild animals generally avoid harming this type of crop. So these crops are actually planted in this region to improve the livelihood and to stop the migration of the people. Secondly, HIMCON has its own nursery in which it develops seedling of oak, rhododendron, broadleaf trees. And then these trees are planted in the spring shed area with the help of Mahila Mandal Dals or with the help of volunteers. These broadleaf trees actually help in infiltration in soil water recharge, and they act as the the leaf that is present or the debris leaf litter that is present in the forest floor act as a sponge, and they reduce the surface runoff. They facilitate the filtration and increase the volume of groundwater. Other activity includes some activities are HIMCON is presently focusing on increasing livelihood of villagers by using agriculture waste for producing mushroom. By mushroom cultivation, livelihood opportunities are being provided to these villagers. HIMCON was founded with a vision to protect. Okay, I have discussed this. Next slide. Next is spring shed intervention. With the help of HIMCON and the volunteers and students, we have done some spring shed intervention in the spring shed area to protect the spring shed area, to increase the infiltration of rainwater to recharge the spring so that the spring is functional throughout the year. It does not become defunct in early summer. So some of the spring shed interventions are: first type of intervention is known as structural or engineering intervention. Structural or engineering intervention involves the construction of physical infrastructure to manage water resources effectively. These interventions are typically aimed at enhancing groundwater recharge, reducing soil erosion, and controlling surface runoff. Some common structural interventions include percolation tanks, recharge pits or trenches, and contour trenching or terracing. In the next slide, we can see that the first figure is of a recharge pit. Second is percolation pit. Third is recharge trench. And fourth is your contour. We are contouring or we are making terraces so that we can prevent soil erosion in the hilly area and we can increase infiltration of rainwater. So these are some structural and engineering interventions to capture the rainwater and to recharge the springs, to recharge the aquifers that are present in this region. Next intervention is vegetative measures or vegetative intervention. Vegetative measures focus on restoration and conservation of natural vegetation to promote ecological balance, soil health, and water retention capacity. Vegetation plays a crucial role in enhancing groundwater recharge, reducing soil erosion, and improving overall ecosystem resilience. Some common vegetative measures include: first is reforestation and afforestation. Generally, for reforestation, afforestation, locally available native species are used. Generally, locally available native plants that serve as fodder for animals are used. These plants are planted. Native fruit trees are planted so that it can provide a source of income, additional source of income to the villagers. Then second vegetative measure is grassland management. Because villagers are solely dependent on these open areas to collect grass or fodder for their animals. Managing grasslands through rotational grazing, controlled burning, and reseeding helps in maintaining ground cover, improving soil structure, and enhancing water infiltration. Healthy grasslands act as a natural sponge, absorbing and storing rainwater for gradual release into springs and streams. We all know that if there is an open area, then it will cause more soil erosion. So by improving grassland management, we can reduce soil erosion and we can increase the infiltration of rainwater and groundwater recharge. Next is agroforestry systems. Integrating trees and shrubs into agricultural landscapes through agroforestry systems improves soil fertility, regulates microclimate, and enhances water retention capacity. We know that the area that has tree or forest cover, they generally receive more rainfall than an open area. Further, the root system, the root network of the tree, a big tree, they actually provide a pathway for groundwater to enter into the deeper crevices of our soil or different bedrock. Next slide. Here, vegetative measures are shown. In this figure, first photograph is of nursery where your native plants are grown. This plant is of rhododendron. This plant is known as buranch, and this plant is used to make a local juice, and it is considered that the buranch juice or rhododendron juice has medicinal properties. So these trees are developed, seedlings are developed in the nursery, then it is provided to the different stakeholders or women to plant in the spring shed area. This is a local fodder crop which is being distributed to the women so that they can plant them in their areas, in their villages, so that availability of fodder can be maintained. Next slide. In this next slide, first photograph, the different stakeholders are reseeding the field. In this area, you can observe that these are actually contours that are developed to reduce the runoff to increase the rainwater recharge. Then second diagram is of a walnut tree. It is, we all know that, a acroot plant. Then third diagram is a method of composting, vertical composting method. In this method is known as Shivan's composting method, and through this method we can produce compost organic fertilizer within few weeks. And this type of composting was spread, awareness was created to the villagers so that they move to organic farming. They use lesser fertilizers, synthetic fertilizers. The next plant is mango plant, and different type of fruit plants are planted in this region. Next slide. After identifying the springs and after identifying the recharge area of the springs, the water quality analysis is done of various springs. The water samples that were collected from the point of spring emergence from different springs of Sabli village, Tehri Garhwal region. Water samples were analyzed following the standard methods prescribed by AFA 1998 and Trivedi and Goel 1986 for examination of water and wastewater. All necessary precautions were undertaken during sampling, on-spot analysis, and transportation of water samples to the laboratory. Generally, when water sample is collected, some parameters are measured on the spot, like dissolved oxygen, like temperature, like free carbon dioxide. It is measured on the spot. Then water is taken to the laboratory, to the research institution where we are analyzing the water sample as soon as possible. Then through different methods that are prescribed by AFA and by Trivedi and Goel, these samples are analyzed. Next slide. This slide includes physiochemical characteristics of spring water. You can see the discharge area of the various spring. For example, Suridhara produces around 34,560 liters water per day. Pani Ka Khal produces 6,646 liter waters per day in the month of April. Muria Parihar spring produces 57,600 liters of water per day. Muria Parihar 2, that is a lower spring, produces 28,799 liters water per day. Os Ka Pani spring produces 14,400 liters water per day. Chamari Dhara spring, actually it is a seepage spring, it produces very less quantity of water. It produces 864 liters water per day. This water is utilized by Himpon. A tank is constructed near Chamari Dhara, and this water is used for the nursery purpose, for the propagation of plant in the nursery. This water is utilized. Then the last spring is Moriao Dhara, that is present on the roadside near the highway, and it produces around 4,035 liters water per day. We can see that the water that is present in this springs, they are slightly alkaline, and thus there is a belief that the alkaline water helps in better digestion and it has therapeutic uses. And then various parameters are mentioned here. For example, we can see that BOD is present, higher BOD is present in various springs, and it signifies that there is pollution. There is pollution in this groundwater. Next slide. Now, I'm concluding my research, and we are going to summarize the key concepts. So what we all need to revive the drying Himalayan springs. So there are four important factors. First, we are going to see what are the various threats to the Himalayan springs. First is deforestation. Second is climate change. Third is unsustainable water use. Fourth is water pollution. Then second is impacts of dry springs. What are the main impacts? First is water scarcity, agricultural disruption, ecosystem degradation, and threats to the rural livelihoods. And it may cause migration of the youth. Then spring shed interventions that are done to protect the springs are reforestation activities, water conservation measures like construction of recharge pits, percolation pits, or construction of terraces, terrace farming. Then community engagement with the help of Mahila Mandal Dals, with the help of your school students, with the help of volunteers, or with the help of college students, we can carry out different type of research. We can carry out water quality analysis. We can carry out the spring discharge studies. Then sustainable water management practices. In some areas, even sprinkler irrigation is now used in some parts of these villages, even because water availability is very less. Now farmers are using sprinkler irrigation. Even the various houses now have your rainwater harvesting structures. They have developed a tank in which this water is stored, so that during summer or early summer, when there is less water, they can use this water. Then last is outcome of the revival effort. What is the outcome of this research? It would result in increased water availability, restored ecosystem balance. It would improve the livelihoods of the locals, and sustainable water resources. Next slide. The way forward, what we can do to protect the spring in this region, in Himalayan region or in Western Ghats. So we have to be the voice for the change. Let's be the advocates our spring needs. Just like a chorus of voices in a song, each of us has the power to ensure policies safeguard our beloved springs in Tehri Garhwal. Together, our voices form a symphony of change. Second, we can support spring revival, extend a helping hand to our spring revival efforts. Imagine each donation, each fundraising event, and each volunteer as a small seed planted in the soil, nurturing the growth of our springs back to the health. Third is getting your hands dirty. Dive in and get your hands dirty, quite literally. Think of your involvement in spring shed management activities as planting seeds of hope. Next is spread the word, share the story of our springs with others. Together, let's ignite a fire for passion for spring conservation that spreads far and wide. Next. So we have come to the end of the presentation. And in this figure, we can see this is a Himalayan spring, and this is a special container in which water is collected. I would like to end my presentation with a quote that, like a fresh spring flowing from the heart of the Himalayas, may our spirit be pure, ever renewing, and ever inspiring. Thank you.
So thank you, Dr. Sahaji, for the nice presentation. Springs are definitely very close to our hearts. I think everyone present here, the springs, I of course enjoyed, because spring is such a subject that is very dear to everyone's heart. कहते ही हैं पहाड़ों की खूबसूरती का कोई जोड़ा नहीं है, और
जीवन कितना कठिन है वहाँ।
बहुत तो है, और अगर स्प्रिंग्स भी ड्राई हो रहे हैं तो और कठिन हो जाए,
फिर उसमें कुछ ज्यादा ही
कठिन है निश्चित रूप से। और एक्चुअली जो हिल्स का जो इकोसिस्टम होता है बहुत फ्रेजाइल है ना, बहुत फ्रेजाइल है, थोड़ा सा में बदल जाता है। और आपने जो बताया वो किस तरह से वाटर की स्कैर्सिटी सब लोग देख रहे हैं, हिल्स में भी है, और स्प्रिंग्स भी कई सारे स्प्रिंग, आई एम श्योर कि आपका जो स्टे पीरियड होगा उसमें भी कुछ गायब हो गए होंगे, है कि नहीं? तो जिसका असर पूरे इकोसिस्टम पे पड़ता है निश्चित रूप से। एक चीज मैं जानना चाह रहा था, बिकॉज कि वो आपने देखा है वहां पे बीओडी भी आया है,
हाँ.
है ना? और दैट लुक्स वेरी स्ट्रेंज apparently.
So it is not required
हाँ
to
हाँ,
test the BOD of
no,
the
no, it is nice that you have examined it for BOD, but what is the source, why it has come? Because ना जो स्प्रिंग वाटर है उसको तो हम मानते हैं एकदम प्रिस्टीन क्वालिटी में।
So even in the
Fresh
plains,
हाँ हाँ
we consider that our boring is the best.
हाँ हाँ,
It is purest form of water.
Right.
But we know that there are different sources of groundwater pollution.
नहीं कंटामिनेशन हो सकता
There is
है।
contamination. In hills, there are several sources of contamination. First is pesticides. In this region, now actually the locals, they have shifted to the major cities, and people from different region, like from Nepal, there are some settlers and they are growing vegetables, like they are growing cucumbers, they are growing tomatoes, and they are using huge quantity of insecticide, pesticide. And due to indiscriminate uses of this pesticides, insecticide, these groundwater sources are getting contaminated. Then there is a shift now. We can see that every person that is from plains, they want to have a holiday home in the hills.
हम्म,
They want to get a land in Nainital. They want to get a land in Manali. है ना? So when they enter this area, they do not follow the local norms. When they create their houses, the wastewater, there is not proper drainage or sewage supply. Sewage is not there. Sewage system is not there. So the wastewater
gets contaminated.
gets seeped and it contaminates, or your septic tank leakages are sources to this contamination.
Also, the wildlife excreta also contributes.
ठीक है, वो इनफैक्ट
तरीके से उतना नहीं होगा। एक संभावना ये भी है कि जहाँ पर ये लोग टैंक खाटू में जो टैंक बना है,
Yes.
इसमें लीक वगैरह जो
हाँ,
हाँ वो भी हो सकता है। लीफ लिटर भी है।
Leaf litter also.
हाँ,
लीफ लिटर भी होता है,
पॉसिबिलिटी है, ताकि BOD हम देख रहे थे हल्का बड़ा
हल्का हल्का बड़ा हुआ है।
और दूसरा एक देख रहा था मैं आपका ये चमारी
हमारी
Yes, sir.
आपका TDS बहुत कम है, उसके रीजन
सर क्या होगा?
इनफैक्ट यू नो मैंने बच्चा लोग के लिए
बाकी जगह तो आपका
ये
ठीक है।
concept of mineral water,
300,
you know,
Yes, sir.
लेकिन
it came from spring water.
Yes, yes.
particular उसमें ना
That's
बहुत
वो कुछ इन्वेस्टिगेशन सर करना पड़ेगा, क्यों रीजन, क्या रीजन देखना पड़ेगा।
तो कम नहीं होना चाहिए।
उतना कम।
So you have any questions?
सर 200-300 है,
The floor is open now for discussion. हाँ,
लेकिन वहाँ पर मात्र 4 है।
क्या कोई क्वेश्चंस है, कुछ बात है?
एक चीज मैं जानना चाहता हूँ, कैचमेंट एरिया, बेसिन एरिया और आपका वाटर शेड एरिया और आपका जो स्प्रिंग शेड, रिचार्ज एरिया में भी सम है,
District में भी
some है. So how we are designating this thing, that is the recharge area, because the continuous space, it cannot be a
sir, for
area.
Sir, for identifying the recharge area, for identifying the spring shed, there are various methods. For example, we can use remote sensing technique. We can use, we have to carry out geological survey of the area. Then we can carry out isotopic studies. We can use oxygen, hydrogen isotopes, and by doing isotopic studies, radioactive isotopic studies, we can identify that where is the recharge area by adding different type of dyes in the, say, in the upper part of the mountain. We can see that if we have put some dye in some particular location, from which spring it is getting released, and then we can identify that this is the recharge area of that particular spring.
Because recharge area will be some recharge area.
It actually happens that a village is present in the north side, and the recharge area is present in the south side of the mountain where there is another village.
Then you will describe it as being shed.
Yes. It can happen that the spring shed of a particular spring particle that is present in a particular village falls in another village. So we need a holistic approach. We need to protect the entire area so that all the springs that are present in different villages can be protected.
So participants who have joined us online, if you have any queries or questions, you are most welcome. तो का कोई क्वेश्चंस है? हाँ, बोलिए.
Sir, as you said, you are pursuing PhD. So what are your objectives? What are your findings?
My main objective first objective was to identify the springs in the area, then to identify the recharge area of the spring, then to identify what are the factors that are causing, that are drying up the springs. Now, second objective was that through spring shed intervention, we wanted to see how these intervention are going to positively affect, are going to recharge the spring. Then second objective is to measure the discharge of the spring. Main objective is to increase the discharge of the drying spring. Then another objective is to measure the water quality, according to the potability point of view. Most of the people are drinking this water. They are considering it as a pure water. So next objective is to see the water quality of the spring. And third objective, main objective, is to develop a model, to develop a computer model through a program, ModFlow program, so that these model can be used to simulate projections that by changing these factors, like by changing recharge, by changing evapotranspiration, by doing some intervention, what results we are getting. So main objective is to develop a model so that this model can be used in different areas.
So model developed earlier.
At present, I am in the process of developing the model.
तो अगर हम लोगों को मॉडल वगैरह सीखना हो, तो क्या सोच रहे हैं?
मॉडफ्लो के लिए तो ऑनलाइन एक मॉडफ्लो, विजुअल मॉडफ्लो करके एक आता है, उसमें है ना, उसमें वो ट्रेनिंग प्रोवाइड करते हैं. ऐसा मैंने भी सर्च किया था, तो इजीली वो अवेलेबल नहीं. तो मैंने डिफरेंट जो रिसर्च प्रोजेक्ट्स, रिसर्च पेपर्स हैं, डिफरेंट थीसिसेस हैं जो लोगों ने रिसर्च कर रखा है, शोध गंगा का या डिफरेंट यूनिवर्सिटीज का, फॉरेन यूनिवर्सिटीज का, उसको मैंने सर्च किया. उसके थ्रू या फ्री बहुत सारे कोर्सेज लोग यूट्यूब पे प्रोवाइड करते हैं, उसके थ्रू आप थोड़ा सीख सकते हैं. नहीं तो अगर आपको प्रॉपर स्पेशलाइज ट्रेनिंग चाहिए तो NIH रुड़की है, वहाँ पे आप किसी एक्सपर्ट्स के साथ या अदर जो एक्सपर्ट्स जो मॉडलिंग कर रहे हैं उनके साथ आपको कुछ रिसर्च कैरी आउट करना होगा. या अगर हम PhD कर रहे हैं तो उनको गाइड बना के साथ में वो रिसर्च करें.
So exactly what we were discussing yesterday. नहीं, जो हम लोग बात कर रहे थे, सर ने जो आइडिया दिया था.
Modeling.
Now you can correlate.
Sir,
So,
we can do also the analytical modeling using ModFlow or in the QGIS or ArcGIS platform also.
Then
For hydrogeological mapping or for land use, land cover and all that.
yes, we can also prepare a conceptual model. It is a easy way out, but the computer model is more better.
So इस तरह से आप लोग भी कोई सब्जेक्ट उठा सकते हो, है ना? Not exactly spring तो आपको मिलेगा नहीं प्लेस, है कि नहीं? But of course water bodies are there, lakes are there, ponds are there, जिसके ऊपर हम लोगों ने कम काम किया है ना? अंडरग्राउंड वाटर, रिवर, उसके तो करें. तो इस तरह से कई सारी चीजें हैं. स्प्रिंग्स भी हैं. इफ यू गो टू राजगीर, पानी है ना, मुंगेर है, कहीं है, तो वो उसको भी टेकअप. सो यू कैन जस्ट एक्सप्लोर हाउ बेस्ट यू कैन यूटिलाइज ऑल दीज इंफॉर्मेशन. और अगर कभी डॉक्टर साहब तो पटना में ही है, इनकी जरूरत हुई तो आई थिंक ही विल बी अवेलेबल, है ना?
So that a bridge can be created.
So our idea is, सर ने कल बहुत अच्छी बात कही कि बस आप लोग को शुरुआत करनी है, we are with you. So ये सब प्रोग्राम भी है, जस्ट एक कंटिन्यूइंग एजुकेशन प्रोग्राम है, एक रास्ता दिखाने के लिए, right? So now I would like to request Chairman sir for his way forward comments.
Thank you very much, Dr. Abhinav. In fact, in Rajgir, we have taken up one project of eco-restoration, and it was taken in 2012 or 13, and within 4 or 5 years, the whole scenario has changed. Here we have used that watershed delineation, first point. Second is the drainage line treatment. And no afforestation was what was done. In fact, what happened when we have the moisture regime in the soil has increased, the number of plants has moved. So we started in Rajgir, and now we spread in all the forest areas of Bihar. Totally, we have 1.85 lakh hectare development in Bihar. Bihar is the first state to start this project. And later, the working plan code, those who are interested in forestry engineering, there is a code that the forestry practices are according to this working plan code. So the government of India has adopted the watershed development as a core area for restoration of any forest. The spring shed development is a part of it because your watershed is a large area. A spring we are focused on this. In Tehri, Garhwal or in the hilly area, people are very. In fact, the whole life is depend on these haras.
Yes, sir.
In Garhwali, we call it hara. And all the settlements, all the villages are near the haras.
Yes, sir.
Nowhere else. So that is why they have taken the project for spring restoration. In fact, it is the restoration of the large area of watershed, the watershed of the whole region. As far as contamination is there, because there is no sewage system, many of the area except Ranikhet or Nanisha and Basuri. In other areas, there is no sewage system. So all the sewage tanks are standalone. Some disturbance is there, something is there, some landslide is there, then they are broken. And they are contaminated springs of the region. That was a very big problem. So if we can able to treat the springs, the watershed of these springs, then we will able to solve this problem to some extent. The next topic. The next topic is carbon capture, utilization, and storage. Present scenario, future perspectives by Dr. Kumar Khasra. In fact, it is a very important topic. We are all are talking about the reduction in emission, but it is about the sequestration, mostly the engineering side, carbon capture and other things, not the biological side. So let's hope for this 24th April.
This is 24th of April, we will having this very discussion. So
Meanwhile, you can read the paper by Dr. Patra, which is there in the group.
And accordingly, sir has requested. He has accepted.
Because I've read the paper.
I think the share it here. So it would be nice that lecture के पहले अगर आप इस पेपर को पढ़ लो
Yes,
तो फिर it will be easier to
understand.
है ना और फिर कुछ बातें आती हैं दिमाग में तो उसको भी हम लोग
Question,
Okay.
we can set questions also.
Right.
But the speaker will be from IIT Kharagpur.
So today we had a very nice presentation by Dr. Abhinav Sahaji. So let us give him a big hand. And I would like to request our chairman sir to present a memento on our behalf to make this occasion a momentous occasion.
All right. Thank you.
वो मोमेंटो का खासियत है सर तो ठीक है I am reminded by my colleague just to share with you that this small piece of memento
And Korea
is special on so many counts. आप इसमें देख रहे होंगे बिहार का मैप नजर आ रहा है
जी सर।
और गौरैया नजर आ रही है ना, स्टेट बर्ड है। और आज 20 मार्च गौरैया दिवस भी है। और आगे की ये इसमें जो भी आप आर्ट वर्क देख रहे हैं, इसमें कोई केमिकल पेंट नहीं है। और जो डिफरेंट शेड्स आप देख रहे हैं, इधर भी दिखा दीजिए, बाकी लोग अगर नहीं जानते हो, तो ये जो डिफरेंट शेड्स नजर आ रहा है गौरैया का, वो किसी कलर के द्वारा नहीं है, वो डिफरेंट कलर्स ऑफ वुड है ना। उसको ऐसा डिजाइन किया, इसमें कोई पेंट, कोई कलर, कोई आर्टिफिशियल केमिकल कुछ नहीं लगा।
वुड का ही नॉर्मल शेड,
जो नॉर्मल शेड्स, नेचुरल शेड्स है, और उससे ये पूरा ये आर्ट वर्क बना है। और वी आर वेरी प्लीज टू प्रेजेंट दिस टू यू, सो दिस विल रिमाइंड योर एसोसिएशन विद अस। और कार्यक्रम में आगे बढ़ते हुए मैं अपने आप को प्रिविलेज महसूस कर रहा हूँ टू प्रपोज ए वोट ऑफ थैंक्स। और सबसे पहले मैं इस परिषद के चेयरमैन सर डॉक्टर डी.के. शुक्ला जी को धन्यवाद देना चाहता हूँ कि सर का जो एक मोटिवेशन रहता है और जो ब्लेसिंग रहता है साइंटिफिक टेम्पर के साथ ये करने का, वो उसी को मेंटेन करते हुए हम इस तरह के सीरीज का आयोजन कर रहे हैं, जो कि नॉट ओनली फॉर आवर ऑफिसर्स बट और भी जो हमारे पार्टनर ऑर्गेनाइजेशंस हमारे साथ जुड़े हुए हैं, सबों को जो करंट इससे है जोड़ता है। और थैंक्स आर आल्सो ड्यू टू आवर मेंबर सेक्रेटरी, बाय चांस ही इज नॉट हियर because of some pressing engagements. He was expected to present a lecture at one of the sessions also that is going on forestry and climate change, being organized by the department, and many other meetings. So in absentia, I am expressing a vote of thanks to him because he has been a constant support in all these type of activities in which we are engaged. और very special thanks to Dr. Abhinav Sahay ji for accepting our invitation and thank you, and sharing his work with us for the benefit of our participants, and we look forward for future interactions also. So, and I would like to give our thanks to all my colleagues, especially Dr. Sahaji, who has been constantly working for this lecture series right from its inception, and always he looks to contact this whole person कि हमारा ये सीरीज चलता रहे। और but yes, thanks to you, कि इसी बहाने हम लोग का जो आउटरीच है वो भी बढ़ा है। Now we have so many friends in the community and to share and exchange our ideas and knowledge. I would like to thank all my colleagues, Arun ji, Dr. Mandal, PRO साहब, वो सोच रहे होंगे कैसे जल्दी से हमको रिलीज बनाना है। So is always very busy, but nice that you are present here, and a special thanks are due to our young colleagues. आप लोगों के साथ काम करके अच्छा लग रहा है ना, और इन सब एक्टिविटीज को प्रमोट कीजिए, और सारे जो भी हम लोग बात करते हैं उसको आगे बढ़ाने की कोशिश कीजिए। और ये जो आज का लेक्चर है ये इसलिए भी बहुत इम्पोर्टेंट है कि अभी आने वाला 22 मार्च को हम वर्ल्ड वाटर डे सेलिब्रेट कर रहे हैं, है ना। तो इस वर्ल्ड वाटर डे के सेलिब्रेशन के ऊपर आई एम वेरी हैप्पी दैट वी आर टॉकिंग अबाउट conservation of water, because water scarcity is a big problem that we all are facing today. Every day आप पढ़ते होंगे पेपर में कि फलाना एरिया ड्राई हो गया, कहीं मारा पीटी हो रही है, कुछ हो रहा है, कभी हम वर्ल्ड वॉर की बात करते हैं। तो वाटर का ये जो कहने को, ये हमारा प्लैनेट ब्लू प्लैनेट जरूर है, लेकिन इफ यू look into the facts and figures, there is very little water left for us and for our future generation. So it is our duty कि हम उसका बेहतर से बेहतर इस्तेमाल करें। मुझसे कई बार लोग पूछता है कि भाई एज ए ये सब आप बड़ी बड़ी बातें कर रहे हैं, पोल्यूशन कंट्रोल, कभी वो क्लाइमेट चेंज और कभी कुछ और ओजोन और दिस और दैट, बट एज ए सिटीजन व्हाट वी आर एक्सपेक्टेड टू डू। तो जो मेरा इंस्टेंट आंसर होता है कि एज ए सिटीजन, एज ए कॉमन मैन, अगर आप दो काम करें कि वाटर का कंजर्वेशन करें और दूसरा एनर्जी का कंजर्वेशन करें, तो उससे ज्यादा आपसे कुछ उम्मीद नहीं करना है। अगर ये दो चीज कर रहे हैं तो आप देखिए इसका कितना रेमिफिकेशंस है, राइट। तो वाटर का कंजर्वेशन उतना ही महत्वपूर्ण है और ये बहुत ही जरूरी है। नहीं तो आने वाले समय में कभी मैं सोचता हूँ तो लगता है कि भाई जो आगे का हमारा जनरेशन है, व्हाट लाइफ दे आर गोइंग टू
नो
फेस,
वाटर नो फ्यूचर।
तो बहुत मुश्किल है।
सर अभी तो बैंगलोर में भी प्रॉब्लम
हाँ, सब जगह मिलेगा, बैंगलोर, मद्रास, कहीं
पोहा खाते हैं सर।
जिस तरीके से पॉपुलेशन इंक्रीज हो रहा है सर।
मैं हमेशा कहता हूँ वी आर वेरी फॉर्चुनेट एंड लकी दैट वी आर लिविंग इन दिस पार्ट ऑफ द वर्ल्ड जहाँ की आपको पानी अवेलेबल है। अदरवाइज इवन इन इंडिया, नॉट इवन इन इंडिया, इन बिहार आप कई सारे इलाकों में चले जाइए, है ना, गया में देखिए पूरा अनुरागपुरी कॉलोनी जो है वो खाली हो गया। और सबसे बड़ी बात,
पानी लिया है मैंने।
गंगा वाटर को पहुंचाना पड़ा।
हाँ, सब पहुंच जाएगा।
दरभंगा शहर,
फल्गु में पानी ले
सर, दरभंगा शहर जो कि पोखर के लिए जाना जाता है कि नहीं, पान मखाना और क्या बोलते हैं आपकी, और पोखर माछ के लिए जाना जाता है। और उस दरभंगा शहर में आपको पानी टैंकर से भेजना पड़ा ना। तो ये अभी हम लोग वर्ल्ड वाटर डे 22 तारीख को से ही करेंगे, उसी के उपलक्ष्य में कहिए आज का ये बहुत अच्छा टाइमिंग भी रहा कि वी ऑल आर डिस्कसिंग अबाउट कंजर्वेशन of water and restoration of water bodies, right? So with all these words, a big thank you to all of you once again. Thank you. Oh, refreshment bhi hai. Oh, I am told that there is a scope of refreshment.
इनवाइट करिए।
So you all are invited to, sir.
हम लोग कर लीजिए भाई।
अच्छा सर, भिजवा देंगे सर।
चलिए, थैंक यू।
So please stay here for some time. I hope it will be served soon.
Yes, we are also thinking to have MOU with them.
Nice.
With the IMT.